Hello guys, I hope you're having a wonderful day. So today I'll be explaining the physics AMS quiz of term 1 week 7. So let us start. Drag and drop the equation that relates the moment of a force M to the arm of moment D, perpendicular, and the magnitude of the force F. So let us say, for example, we have this object, okay? And we have that this is our axis of the object, this is the axis of rotation. Now they're telling us we have a force M. So let's say our force is like this. This is our force M. So if we prolongate our force M, alright, we're gonna see that it does not enter through the axis, which is what we need. As long as it doesn't enter through the axis, then we can continue. So here it's not entering through the axis. And they're telling us the perpendicular distance. So from the axis to the force, the perpendicular distance. So this is what it's gonna look like. Okay, this is our force. Okay, we will call F force, whatever you want, force M, force F. This is our distance. Another word for this is called arm of moment or lever arm. Alright, and this in red is our axis or pivot or what's it called, or the fulcrum, or however you like to call it. So this is what a basic diagram of the moment looks like. So to find and calculate the moment M, we are supposed to do force, our force F or M, however they're labeling it, multiplied by the perpendicular distance. So distance perpendicular, okay, it will be equal to what? To our moment, which we denote like this. So if we look here, which of the following is equal to the equation that we just wrote over here? It is this one. Moment is equal to force times distance perpendicular. Now question number 2. Consider the forces acting on a triangular lamina that can rotate about vertex A. So where is vertex A? Vertex A is over here. This is our axis. How do we know? Because it said that can rotate about. It can rotate around or about this axis, which is called vertex A. Now they're going to tell you which of these forces will produce a turning effect on the lamina. You have to pay attention in the exam. You have to read. Is it produce or is it not produce? Here they want produce. So for produce, it has to not be entering through the axis. So as long as it doesn't enter through the axis, we will see now how we prolongate or elongate the force. And we will see if it enters the axis or not. So let's start with force 1. Directly force 1, we see it is in the axis. So force 1 does not do a rotation. It does not produce a turning effect. Force 2, if you elongate it, if you prolongate it, you will see it's not passing through our axis. So force 2 will produce a rotation. Force 3, if we prolongate or elongate it, you will see it's not passing through our axis. So force 3 will do a turning effect. Force 4, however, if we prolongate it, it passes through our axis. So force 4 is not doing a turning effect. And finally, force 5, if we prolongate it, we see that it is not passing through our axis, so it does a turning effect. So the only 3 that do a turning effect are force 5, force 2, and force 3. Now pay attention. Here they asked us produced. If in the exam they ask us not produced, what we could do, what do we choose? We choose the ones that pass through the axis, which is F4 and F1. So that is for question number 2. Question number 3. The moment of F about vertex A. Now this is really important whenever they ask us moment, pay attention, not net moment. Net moment is a different thing. We will talk about it later in the quiz. But here they're asking us about moment. And whenever they ask you about moment, okay, you do not put plus or minus. It will always be a positive value. But however, if they asked us about the torque, then yes, you have to put positive or negative, meaning that you have to find the direction. So consider a horizontal force F is 20 newtons applied to the vertex C of a rectangular frame. AB is 60 centimeters, BC is 80 centimeters. They need the moment, meaning we do not put plus or minus, of F about vertex A. So where is vertex A? Over here. It needs to rotate from over here. And they need it in what? Newtons per meter. Very, very important. We have our force in newtons, but we have our distance in centimeters. So very simply, to change it from centimeter to meter, we are going to divide by 100. So this will become 60 divided by 100. Let's do it together on the calculator. It is 0.6, and 80 divided by 100 is 0.8. So now we have our distances in meters. So let's forget about centimeters now, because we got our value in what? In meters. So no, sorry, that was 0.8 or 0.6. Yeah, here's 0.6 meters and here is 0.8 meters. Now, they're asking us for the moment. If you remember, in question 1, we got the equation that moment is equal to force times our perpendicular distance. Not any distance, only our perpendicular distance. So they need the moment of F. This is F. First we prolongate it. We see, is it passing through our axis? No, so we say it's not passing through axis. That means the moment is not 0, okay? Since it's not passing through axis, our moment is not 0. If it is passing through our axis, then our moment is 0, so it will not do a rotation. So here it's not passing, it will do a rotation. Let us see. It is force, our force is 20 multiplied by the perpendicular distance. Let's find the perpendicular distance. Between A and the force F, the perpendicular distance is AB. So it is 0.6 meters. How do we know it's 0.6 meters? Because this is a rectangle. Okay, here they said a rectangular frame. So this side over here is equal to this side over here. And this side over here is equal to this side over here. So we know that this is 0.6. So we're going to do 20 times the perpendicular distance, which was 0.6. And we're going to get 12 Newton per meter. So 12 Newton per meter. Why we do not put it negative? Because they asked for the moment. This is the case only if they ask for the moment. But let's say they asked for the torque. Okay, I'm gonna do extra examples here. Let's say they're asking us for the torque. How much would the torque be? We are gonna say that our force is 20 newtons and our distance, we're gonna change them to meters as we did before, so 0.6 meters and 0.8 meters. Now, you know, or we know that if it is going anti-clockwise in the opposite direction of the clock, it is positive. And we also know that if it's going clockwise, that it is negative. This is important for the torque, okay? Now, the equation for the torque is the same, just it is positive or negative force times the perpendicular distance. Our force now is 20 newtons, so we're going to prolongate it. We said it's not passing through our axis, which is A. So now this is very important. Our force is like this, yes? So what you're going to do, because I can't demonstrate it, I will, hold up. I can't demonstrate it physically, but I'm going to say it. You're going to do something called the right hand rule, the RHR. What does that mean? We're gonna take our right hand, okay? Like, take your right hand. If you're left-handed, don't worry, you can still do it in your right hand or in your left hand, but it will be the opposite of what we're doing. But let's follow the right hand rule, okay? the right hand rule says, take your right hand and put it on the force, okay? But your palm has to be facing in the direction of the force. So we know that our force is downwards, not of the force, sorry, my bad. It has to be facing our axis. We know that our axis is downwards, so our palm will have to face downwards. So we're gonna put our hand, our right hand, on the force, okay? And we're gonna see that we need to put our palm downwards. The palm means the inside of our hand, we have to put it downwards. Now, if you notice, I don't know if you guys are doing it, but I'm doing it. My thumb is pointing towards my tablet screen. If my thumb is pointing towards my tablet screen, then it is negative. And we said if it is negative, then it is a clockwise direction. So now, we know that it is gonna be negative F times D. So it's gonna be minus our force, which is 20, multiplied by the perpendicular distance, which we got last time, which was 0.6, and we are gonna get negative 12 Newton per meter. So you see the difference between calculating the torque and calculating the moment? So there is a very big difference. That's why you guys have to read. Question number 4. Consider two forces, each of magnitude 15 newtons, applied to twist a 2 centimeter cap as shown below. Now, the moment of this couple is, here notice they asked for the moment. So whenever they ask for the moment, they don't need it in positive or negative. We will keep our value as positive. So whenever we have a couple of forces, what does a couple of forces means? It means two forces in opposite directions but same magnitude. This is what a couple means. Now, why do we exert a couple? So for example, if you are opening your water bottle, you are gonna put one finger on one side and your other finger on the other side to what? To turn the bottle. You can do it with one finger, but it's very difficult. But if you do it with two fingers and they're in opposing sides and they are putting it in the opposite direction, they are opposite direction forces, then it will rotate. Now I'll explain why it will rotate, even though it's not relevant to this question, but it's very important to know why it will rotate. Because if we're gonna do the right hand rule for these forces, the axis is in the middle, okay? If we're gonna apply the right hand rule for these forces, we're gonna start by putting our right hand rule on this force over here, which we will call force 1. If we put our right hand on this force, we will notice that our thumb is pointing away from our screen, so it is a positive force. Alright? That means it's going in which direction? It is going in the anti-clockwise or the counter-clockwise, however you guys like to name it. Clockwise. Now, we did the right hand rule for force 1. We put our right hand and our palm, the inside of our hand, has to face the axis. This is for force 1. Now force 2, we're gonna do the same thing. So now our hand will be flipped. Our palm, the inside of our hand, has to face the axis, which is over here. And then we notice that our thumb is also pointing away from the screen. So it's another direction. It's like the same direction, but it's for another force. So it is also counterclockwise. So even though they are opposing directions of forces, they will produce the same rotation. So this is what we call a couple. They also have to have the same magnitude, by the way. That's why you apply the same force on both sides of the bottle cap. Now, they're asking us for the moment. Moment means we're not choosing positive or negative, it's only positive, of this couple. We know that the moment for any equation is the force multiplied by the perpendicular distance. Here, you can do it. What is our force? Our force is 15 newtons. Then we multiply it by our perpendicular distance. This, you can do it between both of the forces actually. So you can take the perpendicular distance between both of the forces, which is 2 centimeters. But did we pay attention to what they asked us? No, this is why we have to pay attention in the exam. They asked us in Newton per meter. So that means we have to change the 2 centimeters into meters. So we divide it by 100, it will become 0.02 meters. So now our moment is equal to 15 newtons times 0, this is 15, times 0.02 meters. And so then consequently we are going to get 0.3 newtons per meter, and this is the moment of this couple. Now question number 5. The quantitative meaning it is a number, alright, of the turning effect of a force is called. So let's see our answers. We have lever. No, it's not the quantitative measure of turning the effect of a force. It's not the hinge. Hinge means axis, by the way. It's not the weight, it's not the mass, but it is the torque. Torque or moment. Okay? The torque or the moment is the quantitative measure of the turning effect of a force. Okay? Now, if in the exam they gave us both torque and moment, which I'm very hesitant, I don't think they will actually bring it. But if they ever brought it, choose torque. Torque is more of the meaning. Okay? So the torque is the quantitative measure of the turning effect of a force. Now question number 6. In which direction should he apply the force generated by his hand? Did we read up? No. A mechanic is using a spanner. This is a spanner. Alright, to loosen a bolt. This is our bolt as shown below. In which direction should he apply the force generated by his hand in order to produce a maximum torque on the bolt? So, first of all, 5, if we elongate it, if we prolongate it, it will pass through our axis. Our axis is the bolt or the nut, okay? So, definitely 5, the moment or torque is equal to 0. 4, it has a moment, but the moment of 4 is definitely less than the moment of 3. And the moment of 3 is definitely less than the moment of 2. And the moment of 2 is definitely less than the moment of 1. But if we were to draw a force over here, this force, let's call it for example 6. 6, its moment would be less than 1. Now why? It is because the if you are doing a force that is 90 degrees from the base, for example here, it's 90 degrees from the spanner, okay, it will produce a maximum torque. If they asked us for the minimum torque, then it would definitely be the one where the moment is 0. So maximum torque is always the one perpendicular to our axis and our base. Here I'm gonna call it base, here it's a spanner, okay? Whereas the minimum is what it is 0. It is the force that passes through the axis. So here the maximum torque is applied by direction 1. Question number 7. The figure below shows a body that is free to rotate around G. So we have G, since it's free to rotate around it, it is our axis. A constant force of magnitude 20 newtons is applied to the body. The line of action of the force is 0.2 meters away from G. So if we elongated our force and we drew the perpendicular distance, it is going to be 0.2 meters. Now fill in the blanks using terms from the box below. They're asking us for the magnitude. Watch out, they didn't ask us for the value, they're asking us for the magnitude. So whenever they ask us for magnitude, we don't take positive or negative, we only take the positive value. So the magnitude of the moment of the force acting on the body. We said to calculate moment, it was our force times our perpendicular distance. This is the only equation we're going to use in the full chapter, by the way. That's why it's really easy, okay? So our force is 20 newtons multiplied by our distance, our perpendicular distance, which is 0.2 meters. We are going to get what? 4 Newton per meter. So the magnitude of the moment acting on the force is 4 Newton per meter. Now, in which direction is the body rotating? We're gonna take our force. Our force is colored blue. صح? This one. We're gonna take our right hand. Always remember, right hand. You know, sometimes in class I mix up and put the left hand. Don't do like me and be dumb and do silly mistakes, and use your left hand instead of your right hand. So use your right hand. If you're mistaken from left and right, this is left, this is right. Put your hands left, right. Left is the one that makes an L shape if you want with your fingers, okay? So you take your right hand, you put it on the force and the inside of your hand. So let me draw a hand. I know it's a bad hand, but this is our hand, okay? You take the inside of your hand, which is the palm inside, and this palm of your hand, the one where you see the veins, okay? It should be facing towards G. So if we were to do it, you put your right hand on the force, 20 newtons, your palm, the inside of your hand, faces the axis G, and you will see that your thumb is pointing away from the tablet. If the thumb is pointing away from the tablet, it is outward, meaning away or outwards from the tablet, then it is in the positive direction. So the body is rotating in the positive sense of rotation. So we can make it a rule. Thumb away from screen equals out of plane positive and counterclockwise. This is if your thumb is pointing away from the screen. However, if your thumb is pointing towards the screen, so thumb pointing towards screen. I forgot how to write screen. Oh my goodness, screen. Okay, then that means it is in the plane. It is negative, and it is clockwise. So this is for your thumb pointing inside or outside. Number 8. A force F of magnitude 40 newtons is exerted on a square lamina of 2 meters. This force creates a moment of negative 40 newtons per meter about point A. So our axis is point A. P, R, S, T are all midpoints of the square's sides. Okay, what are the possible points of application of F? So we got that the moment is what? Negative 40. Oh, look, it's negative. We said if it is negative, that means our thumb is supposed to be inwards, it's in the plane, and it is clockwise. So, while doing the right hand rule, we have to pay attention. Is our thumb pointing inwards or outwards? Is it in the clockwise direction or in the anti-clockwise or counterclockwise direction? So let's start. First of all, most importantly, we have to prolongate. So let's prolongate P. If you prolongate P, it's not passing through our axis A. So definitely we can use P. So we're going to do the right hand rule. We're going to put our right hand on P. Oh my goodness, sorry. We're going to put our right hand on P. And our palm, the inside of our hand, has to be facing A. If you notice, your thumb is pointing outwards, but us, we need it what? We need it inwards. So definitely P is not the force that created this moment. Q, let us prolongate Q. It passes through our axis, so the moment is 0. So it's definitely not the force that made this moment. R, let's prolongate R. R doesn't pass through A, so we can use it. Let's use R. We're going to do the right hand rule, and we are going to put our palm facing to our axis. Our axis is upward, so we have to put our palm upward. And so if you notice, your thumb is going to be pointing towards, away from you. So it is outwards. Your thumb is then outwards. So it's not what we need, so R is definitely not the force that caused this moment. S, if we prolongate S, it does not coincide, it does not pass through our axis A, so we can use S. If you notice, S is downwards, it's pointing downwards. To where the arrow is pointing, we have to put our fingers. So if we put our fingers in this direction, and we put our palm towards where the axis is facing, our axis is facing here, this side, so we put our palm towards this side, you will notice that our thumb is pointing inwards, and us, we need it to point inwards. So one possible value is S. S is possibly the force that made this moment. Now, finally, last but not least, we have T. If you prolongate T, it's not passing through our axis. Now, we're going to do the right-hand rule for T. We're going to, since T is pointing towards the left, we have to put our fingers towards the left. And our palm should be facing upwards, because that is where our axis is. And if you notice, your thumb is inwards. So this is what we need. That means S or T are the forces. T and S are the possible points of application of our force that created this moment of negative 40. Question number 9. ABCD is a rectangle of sides 10 centimeters by 12 centimeters as shown below. 3 forces are applied to its sides. Force F1, 8 newtons, is applied vertically upwards at midpoint of BC. Force F2 is 10 newtons, is applied at C along the diagonal AC, and force F3, 4 newtons, is applied rightwards at midpoint of CD. Now, the net moment of these forces here, I told you, pay attention. They want moment or net moment, they need net moment. So whenever they're telling us net moment, we have to use the plus or minus. So let's write the forces. Force 1 is 8, force 2 is 10, and force 3 is 4. So force 1, 8 newtons, force 2, 10 newtons, and force 3 was 4 newtons. Now the net moment of these forces, we're going to start by calculating the force of F1, and then we're going to add it to the force of F2, and then finally to the force of F3. First, let's prolongate F1. You will see it's not passing through our axis because they said the force is about point A. It's not passing through our axis A, so we can use it. Now we need the perpendicular distance from A to F1. So we're going to find the perpendicular distance. It is this value over here. If you know in the rectangles, if you cut this and you draw the diagonals and something like this, it will cut this value in half. So this is 6, not meters, 6 centimeters. All right? So we have the force for our first force, and we have the distance, the perpendicular distance. So we can apply the moment. Moment of F1 is equal to force times perpendicular distance. Force is 8 newtons multiplied by the perpendicular distance, which is 6 centimeters. Now, let's find the moment of F2. Let's prolongate F2. If you see, it's passing through our axis. So the moment of F2 directly is equal to 0. If it passes through our axis, the moment is 0. And now finally, for the force F3, if we prolongate it, we see it's not passing through our force, through our axis, sorry. And then if we are going to find the perpendicular distance from A to F3, it is this over here. Now again, it's going to cut side BA into half. So it is going to be over here 5 centimeters. So now the moment of force F3 is 4 newtons. So moment force F3 is 4 newtons multiplied by 5 centimeters. But we did not finish yet, alright? We need to now find the direction. Why? Because they asked us for the net moment. So we remember if our thumb is inward, it's negative. If our thumb is outward, it is positive. So let's do the right hand rule, RHR. Okay? We are going to take our right hand, we are going to put it on F1. Now it has to be pointing into the direction of our axis. Our axis is here, so our palm, has to be pointing to this direction. Okay, and so we are going to get that our thumb is pointing outwards. So the sign for moment of F1 is going to be positive. Moment of F2 is 0. 0 is 0. You cannot put it positive or negative. Either way, it's going to give you the same result. Now, the moment of F3. Where is F3? It's over here. So we have to put our fingers pointing to where the arrow is pointing. Okay. Then we have to put our palm to where the axis is. If you notice, our axis is downwards, so our palm has to face downwards. Then we get that our thumb is facing towards the screen. It is inwards. So the sign of moment of F3 is negative. So if we are going to solve, we are then going to get that the net moment is equal to positive 8 newtons times 6 centimeters. Now pay attention here, they needed in newtons per centimeter, so we keep it in centimeters, okay? Plus what? Negative 4 newtons times 5 centimeters. So if we do this on our calculator, it is 8 times 6, okay, minus 4 times 5, and we are gonna get that the net force is equal to 28 newton per centimeter. So if you noticed, it's all the same equation. So here the answer is 28. Number 10. Consider the forces F1 and F2 that act on the plank which can rotate on the triangular fulcrum. This is our fulcrum. Since the plank can rotate on this fulcrum, that means this is our axis. The moment of F1 about the fulcrum. So we don't have any values. We just need to know that F1 is here. They need the moment of F1 is directed. So we're going to do the right hand rule. And we're going to put our right hand on F1 and our palm has to face the axis. So if you notice, it is in the plane. So we're going to say into the plane of the picture. So F1 is into the plane of the picture. And we said if our thumb is pointing inwards or into the plane of the picture, or it's pointing towards our screen, then it is negative. So for the first one, the moment of F1 about the fulcrum is directed into the plane of the picture and is negative by convention. Now the moment of F2, again, this is our axis. We're going to take F2, we're going to put our right hand, and we're going to put our palm facing towards the axis. If you notice, our thumb is pointing out of the plane of the picture. So it's pointing outwards, and we said if it was outwards, it's going to be positive. So the moment of F2 about the fulcrum is directed out of the plane of the picture and is positive by convention. So that was for question 10. Now question number 11. A person is pushing a box across the rough horizontal floor. The box gets stuck at the door stopper as shown in the diagram below. Which of the forces acting on the box will produce a clockwise movement? Okay. Clockwise movement meaning negative, meaning our thumb faces inwards. So let us check at our options. We have weight, friction, push by a person, and reaction of the door stopper. So our options are the weight, then the friction, Then the reaction of the door stopper, let me do it a different color. The reaction of the door stopper, I will call it R, and then the push of the person, which we will call it P. Then they need a force that produces a clockwise movement. Clockwise meaning that our thumb is inwards or towards the screen, and it is negative. So if we're gonna do the right hand rule for each one of them, we're gonna start with, for example, the friction. We're gonna elongate the friction. It passes through our axis, which is the block. So we are not gonna consider friction. Then if we're gonna take the resistive force or the reaction of the stopper, okay, if you elongate it, it also passes through the axis. So we're not gonna choose the stopper because the moment is 0. It is not gonna cause a rotation. Now P, the pushing force of the person on the box, if we elongate it, it's not passing through the axis, so we can use it. We're gonna do the right hand rule. We're gonna put our right hand on P, and our palm has to face the axis, or the stopper in this case. If you notice, the thumb is pointing outwards, so here the it is an anti-clockwise or counterclockwise movement, anti-clockwise rotation. So definitely P is not the one we're looking for, and that gives us left with the weight. If we're gonna do the right hand rule, first of all, let's elongate the weight. If you notice, it's not passing through our axis. So let's do the right hand rule in the weight. Our fingers have to be pointing to the direction of the weight, which is downwards. Our palm has to be facing towards our axis, and you will see that our thumb is inwards. So that means it is a clockwise movement. So the weight of the forces will cause a clockwise movement. And we said that clockwise means negative or inwards. So the conventional sign of the clockwise movement is, negative, not positive. Now, question number 12. The torque of F1 about A. Okay, in the diagram below, force 1 is 5 newtons, force 2 is 20 newtons, force 3 is 6 newtons. AB is 10 centimeters, BC is 2 meters, oh my goodness, not 10 centimeters, my bad, I meant 10 meters. Then BC is 20 meters, and AD is 6 meters, and BD is 8 meters. ABD is a right triangle. Okay. They are looking for the torque of F1. Let's remember, F1 is 5, F2 is 20, F3 is 6. So F1 is 5 newtons. Also, why am I doing this? We need to go up again. Okay. Anyways, the torque of F1, they're asking for the torque. Anytime they're asking for the torque, it can be positive or negative depending on the direction. And the rule for torque, which we will label as T, or in the more professional way, I forgot how my teacher did it. It was like this, something like this, you know? So T, or torque, okay? It's equal to plus or minus force times the perpendicular distance. So they're asking us for the torque of force 1. Torque of force 1 is going to be the force, which is 5 newtons, multiplied by the perpendicular distance. So from F1, they're asking us the torque about what? About A. So again, torque is equal to force times perpendicular distance. So F1 is 5 newtons. It's going to be 5, plus or minus. I forgot the plus or minus. Don't forget it. 5 times the perpendicular distance about A. So look. F1 to the axis A. If you elongate it, it is going to be 0 because it is passing through our axis. So you can do it like this, and you can say that the perpendicular distance between F1 and A is 0, so you're going to get 0. Or you can know that if it's passing through our axis, then the torque is 0. So the answer for the first one is 0 newtons per meter. Now, the torque of F2, the rule for torque is plus or minus force times the perpendicular distance. What is our F2? The force of F2 is 20 newtons, and we're going to multiply it by the perpendicular distance. Where is F2? F2 is here. If we elongate F2, it's going to be like this. It's not passing through our axis A. So far, it's good. Okay? Then we need to find the perpendicular distance from our axis A to our force F2. And here it's given to us, which is 6 meters. So it's going to be force times 6 meters. But now here's the trick. Is it positive or negative? To see if it's positive or negative, we are going to do the right hand rule. So we're going to put our right hand on F2, our fingers facing to where the arrow is facing, and then our palm facing to our axis. And so then we are going to get that it is inwards, our thumb is inwards, so then it is negative. So negative 20 times 6 meters, it is going to be negative 120 Newton per meter. So for B, the result is minus 120 newtons per meter. Now the torque of F3. They need the torque of F3. We know the rule for torque is force times perpendicular distance, and we do not forget the plus and minus. Not plus and minus, sorry, plus or minus. So, first of all, what's the force of F3? It is 6 newtons multiplied by, what's the perpendicular distance between F3 and our axis A? It is 10 meters plus 2 meters, so in total 12 meters. So, the perpendicular distance is 12 meters. Now, finally, is it positive or is it negative? We're going to do the right hand rule. Very simply, put your right hand on the force, your fingers facing to where the arrow is pointing. So here the arrow is pointing upwards, so your fingers have to be pointing upwards. And the palm, the inside of your hand has to be facing the axis A. So if you do it, you're going to see that your finger is pointing outwards. That means it is positive. So it's going to be plus 6 newtons times 12 meters, which is 72 newton per meter. So here, the torque of F3 about A is 72 here, Newton per meter. Now the net torque is when you add F1 plus, you add the torque of F1 plus the torque of F2 plus the torque of F3. So it's going to be 0 plus minus 120 plus 72. And if you do it on the calculator, you are going to get negative 48 Newton per meter. So again, net torque means you add everything. Net force means you add all the forces. Net torque means you add all the torques. Net anything means you add all of the anythings. So net torque is going to be negative 48 Newton per meter. And now after around 40 minutes, we finally reached the last question, which is one of the most important questions. So please pay attention. A spool has an inner radius of 10 centimeters. So that means the inner radius here is 10 centimeters. And an outer radius of 15 centimeters. So from the center to B was 10 centimeters. And then from the center to the external circle is 15 centimeters. A couple of forces, meaning they go in opposite direction but their rotation is the same direction, okay, each of magnitude 200 newtons, applied to the outer radius of the spool as shown in the diagram below. Two more forces that we need to find of equal magnitudes F and of equal magnitudes F are applied to the inner radius. So they're telling us we have a force here, for example, and a force here, for example, that have equal magnitudes F. Okay? They are applied to the inner radius. Actually, not where I drew them. They are applied at points A and B, meaning they would be from here to here and from here to here. So this is F and this is F. So that the net moment on the spool is 0. Meaning you add the moments of, you add moment 1 plus moment 2, then you would be getting 0. If you tried it, you would get that moment 1 plus moment 2 is 0. Why? Because they are a couple of forces. Now the magnitude of the moment created by the 200 Newton force. We know that from the center to the outer circle, our radius is 15 centimeters. So the perpendicular distance from this force to the other one is gonna be also, it's gonna be the radius plus another radius. So it's gonna be 30 centimeters. But do we need it in centimeters or in meters? We need it in meters. So to change it to meters, we're gonna divide by 100. We're gonna get 0.3. So if we're gonna apply the rule for a couple of forces, it is the force. Any force. You take this one, for example, or this one. Just choose one value. It will be 200 newtons. Why? Anyways, they are the same. 200 newtons multiplied by the distance, which was 0.3 meters. So if we're gonna do it on the calculator, 200 times 0.3, we are gonna get 60 newtons per meter. But is it positive or negative? First of all, before asking this question, see, do they need moment, do they need magnitude, or do they need net force or torque? Here they need magnitude, so that means we're not gonna take positive, we're not gonna take negative. So our answer here is 60 Newton per meter. So for part A, the answer is 60 Newton per meter. Now the force F exerted on A. So remember we said here, here. Now why did I draw them like this? I'm gonna explain now. They told us that the net moment on the spool is 0. So that means the moment here plus the moment here is supposed to be 0. So that means they have to go in the opposing direction. So let me put it like this for you guys. If it is closer, which forces are closer to each other, they have to be in the opposite direction. So, for example, this is going towards the left and this is going towards the right. Why are they in opposing directions? Because the net moment of the spool is 0. Okay? This is going to the right. This is going to the left. Why? Because the net moment on the spool is 0. If you did, we will find this value later and I will explain to you this question in a more logical way now that we have the values. So we need to find the moment of this, and we're gonna add it to the moment of this, and it needs to be 0. For this to happen, they have to be in opposing directions. So in the final question, which is to find the magnitude of F, I will explain to you why exactly force F exerted on A must be leftwards and force F exerted on B must be rightwards. So now we need to find the magnitude of F. We know that the net moment on the spool is 0. So our force 1 multiplied by perpendicular distance 1 plus our force 2 times the perpendicular distance of 2 is equal to 0. This is the rule, what? That the net moment on the spool is 0. We have our first force, which is 200 newtons, multiplied by the first distance from this to this one. We calculated it to be 0.3 meters. Now we're gonna add it to what? To force 2, which is unknown. We're gonna keep it force 2, multiplied by the distance. So this is force here, force 2 here, this is force 2 here. So the distance over here, we know that the inner radius from here to here was 10 centimeters. So from here to here is also 10 centimeters. So the total distance from here till here is going to be 20 centimeters. And then in meters, it is 0.2 meters. So times 0.2 meters is equal to 0. If we continue solving, we are gonna get that 60 Newton per meter plus F2 times 0.2 meter is equal to 0. Move 60 Newton per meter to the other side. You're gonna get F2 times 0.2 meter is equal to negative 60 Newton per meter. Then you're gonna bring 0.2 to the other side, and you're gonna divide it. You're gonna get F2 is equal to negative 60 Newton per meter over 0.2, and then finally you get that F2 is negative 300 Newton per meter. But they asked us for what? The magnitude. So we got negative 300 Newton per meter. We're not gonna put the negative, we're only gonna put 300, not Newton per meter, 300 Newton, because this is our force. Now that we have our values, I will explain to you why A has to go to the left and B has to go to the right. So here it's 300 and here it is 200. So let's say we have our axis over here, all right? If we were gonna find the net force, we would take either the ones on top and we add them, or the ones on bottom and we add them. Here it's also 300, okay? So let us say we took the ones on top. What's the rule to find the net moment? It is moment 1 plus moment 2, here in this case, is equal to 0. So force 1 multiplied by distance perpendicular 1 plus force 2 multiplied by distance perpendicular 2, okay, is equal to 0. So now let us substitute. Here is where we need to use the positive and negative forces. If we used the upper ones and we did the right hand rule, we would get that force 1, which is 200, we're gonna say plus or minus 200, because we don't know yet, multiplied by the distance, which is 0.3 meters, plus the force, which is plus or minus 300, multiplied by the distance, which was 0.2 meter. Now let's see, is it plus or minus? Using the right hand rule, okay, we would put our right hand, for example, on force 1, which is 200, and our palm has to be facing towards our axis over here. We are going to get that it is inward, and since it is inward, it is negative. So here it becomes negative 200 times 0.3 plus, if we're going to do the right hand rule for the 300, we're going to do it. We're going to put our fingers pointing towards the left and our palm is pointing downwards. And you're going to see that our thumb is out. Since it is out, that means it is positive. So it's going to be plus 300 times 0.2. And if you do this on your calculator, you will get 0. So you can do it for the up and for the down, you will get the same result. So for the down, the 200 would be positive, and sorry, my bad. Now the 200, if you did it for the down, the 200 is going to be negative, and the 300 was going to be positive. So if you did it up or you did it down, you are supposed to get the same value in where the net force is equal to 0. So let's submit and see. No mistakes, inshallah, ya Rab. Alhamdulillah, thank God there are no mistakes. I hope you guys enjoyed and have a wonderful day.